Welcome to the last session for today on Siemens CNC Turning Guide, a complete guide on stock removal, threading, cutting parameters, reference for either Siemens 840, DMG MORI, EMCO, or even other machines that are used in the industries. Just a basic so that you're able to understand. Unlike maybe Fanuc, most of the Siemens will not use G7, so G71 and G72. If you're using Siemens 808, you can prefer to use class A, B, or C for the G and M code, so that you can now select G21 as the metric, but now use G71 as stock removal along Z-axis. But ensure you initialize that you are using ISO. If you're using ISO for stock removal, you initiate it using G291. Fanuc system, normally Fanuc, Century Star, they normally use G71 and G72 for stock removal. But in Siemens, most of the current one, Siemens because it has their own Siemens controller, not Siemens controller, its own contour editor. They are using Psycho 95, Psycho 97, Psycho 93, and Psycho 98. vis-a-vis G71, G72, G73, up to G74. So you need to understand the mode for each one of them. But the stock removal for Siemens, for example, if you're using Siemens 808, you use this code. For example, G71, it will mean longitudinal stock removal or stock removal along Z-axis. So which means initialize the code first of all with G291, so that when you put G91, you're converting the Siemens the code from Siemens direct to ISO direct, so that you put now G71 U mean the depth per cut, then R as retraction. Then second code you can put a G71 P, the start of the block because it's a cane cycle, Q the end of the block for the cane cycle, U is the finish allowance, and then you put W as a finish allowance plus Z plus F as the feed. An example, you have what you call G71, you put U and R. U meaning this is a stock removal from this is stock removal from here, from depth of cut. Sorry, this is a depth of cut. Let me say stock removal along x-axis. Then R is the traction. Then the second P is the block. Where are you starting from? Where are you ending? Then the finish allowance along X, finish allowance along Z, then feed rate. So this is how the program look like when you're using Siemens 808. You can also use G71. This is the face turning or face roughing along Z. And now you turn along X. You turn along X. You feed towards Z, but turn along X. So you can use G72 W, meaning the depth of pass in the Z. Then you retract. Then start of the block, Q end of the block. P start of the block, Q end of the block, U the finish allowance along X, and then W finish allowance along Z, and then F is the feed. An example is like this: you have this G72 U W first, then R, then G72 P10 Q. This is the start of the block, end of the block, finish allowance along X, finish allowance along Z, then the feed rate. But normally you can configure them. For example, if in a stock removal you're using ISO, as I said initially here, for example Siemens, you have to put G291. Then you put this cancelling any constant cutting speed. Then you put for example speed you need to calculate clockwise direction, put close to maybe this is positioning, this is safety approach. Now roughing the code for turning. You're starting where you're ending, then you where you are ending is this. Now you're starting from here, you're ending from here, then you bring in finishing. Now the finishing you put now G70, then P10, because this is where you're starting, this is where you are ending. This is for Siemens way of programming. So you need to understand the meaning of H, like step G71, this is a stock removal along Z-axis. G72 stock removal along X-axis is like face turning. G73 is spec but repetitive stock removal like a pattern. They say pattern turning. Then G74 spec grooving. G75 also normally used for grooving. Then you have finishing cycle, then basic turning. You can use it as basic turning or absolute turning. So you need to understand the controller you are dealing with. That is very important. Also, in this case, if you are programming, you need to also understand the thread. This one I already explained, the thread guide, how you calculate the passes. For example, in the previous session, I explained the code used for threading: G32, G33, G76, G92, G96, G82, all of them. How you use them for thread. Then at the same time, understand how to calculate the what you call the thread height. Thread height is normally given for metrics, normally given by this formula. So you need to know how to find the height of the thread, maximum radial depth. That is now this h divided by 2, or major diameter minus minor diameter divided by 2. A simple way. Then passes. How you calculate the passes depending on the pitch. Normally, the first pass, either you take 30 to 40% of the radial depth. For example, if the radial depth here was, let's assume the radial depth for, let's use the second pitch here. This is a table you can use. I've put a table. For example, if you're using a pitch of 1, the radial depth is 0.614. So you can now take the passes. It's 30 to 40% of this one. You would get 0.12. So the first pass you take 0.12. The second pass, third pass, fourth, then you finish. Then the last one you normally put spring passes. Normally two spring passes. Spring passes between 2, which it is just to clear the material, but not cutting, to just clear any waste that is remaining. So each you need to refer the table. This is the table for use. For example, first pass normally between 30 to 40% of radial depth. Second pass 25%, third 20%. The final is 10%. Then you have 2 spring passes for the thread. So this is a table you can use. This is a chart you can use for the thread pass, depending on the pitch. For example, as the more the pitch goes, as the number of passes also goes, you can also increase the passes. Then each one of them, like which code can be used for threading. That's why I had already explained the code for threading: G76, G32, G3, G96, G82, and also G92, all of them. Then also cutting parameters, I already explained how you calculate the cutting parameters vis-a-vis the material. For example, the spindle speed, this is the formula for use to calculate the spindle speed. The feed rate, this is the feed rate used. You take the feed, this is the feed. So you take, this is the feed rate, you take the feed times the spindle speed. You get what? The feed rate. Material removal rate, you take the cutting speed times the feed times the depth of cut. Then the VC is the cutting speed, meter per minute. D is the workpiece diameter in millimeter. F the speed per revolution. Then AP is the depth of cut. So this is the formula you have to use when you are calculating these parameters. The material cutting parameters also check for each one of them. They may differ, like maybe mild steel, stainless steel, aluminium. Normally aluminium between 60, 61, 70, 75, brass. All of them may differ depending on the material. So you need to check the correct spindle speed as per the example, depending on the diameter of the workpiece. So all of them will put the correct one. I already have given you a table in the previous session when I was explaining each one of them, so that when you are referring the feed you are going to use, for example, if the diameter is between 10 to 20, the rough feed you can use is this. Then the finished feed you can use is this. Then the rough you can use this. This is general for most of the materials. If you're using the diameter is between 20 to 40, this is the feed you need, rough feed you need to use. This is the finished feed you need to use. This is the rough depth of cut. This is the finished depth of cut. If it is between 40 and 80, this is the rough feed. This is the finished feed. This is the rough depth of cut. This is the finished depth of cut. So each material will depend, but this is a general guideline that you can follow when you are machining your piece. So that the output is good. Then the speed calculator, as I said, you can also calculate depending on the material. For example, if my steel is roughing, maybe the diameter of 63, for example, cutting speed I can able to calculate, then I can calculate the parameters. So it will give me the parameters here that I need to use a spindle speed of 379. I need to use a feed rate of 94. material removal rate of this and cutting time would be 63 seconds. Then this is the formula for you to use. So the reference is you need to understand the material for roughing parameter or cutting parameter for different materials. Each one of them have different finish. If I say finish parameter, if I say calculate, you can give me different parameters. As you can see, these are different parameters it can give. So you need to understand how to compute each one of them. Then on the Siemens cycle, as I said, most of this, the current one like 828 and 840 controllers, they may not use G71, so don't confuse. So maybe they're using cycle 95 for rough turning, cycle 97 for finish turning, which was using G71 and G72, and finishing was using what? G70. Then you have G93 for rough face turning, which was G72. Then you have G98, cycle 98 for thread cutting, which was G76. So it may change. Then you have cycle 92 for grooving, which was G74 and G75. Then you have cycle 971 and cycle 972 for OD turning and ID turning. So you can use them for both internal turning and external turning. So normally these are the cycles that have changed for Siemens 828 and Siemens 840. You may find when maybe it was we are using G71, but now they're using cycle 95 and cycle 971. Maybe G76 they're now using cycle 97. G72 they're now using cycle 93. G74 and 75 they're now using cycle 92. G83, that is back drilling, they are now using cycle 83. So you need to look at the reference for each one of them so that when you are using them, you don't mix.